Welcome viewers. Today we'll be looking at these two equations. X plus y is equals to 9 and xy is equals to 20. From these two equations, we will be establishing what x squared plus y squared is. Just like it is clearly seen, x plus y is equals to 9, xy is 20, and x squared plus y squared is what we are looking for. Now, generally in mathematics, a plus b squared is equals to a squared plus 2ab plus b squared. And that's just the same as x plus y all squared, just like you can see here, is equals to your x squared plus 2xy plus y squared. Let me come again. If you look at the left-hand side, you have your x plus y, everything squared. And if you are going to expand it, that is by opening the bracket, giving us what we have on the right-hand side, it is simply x raised to power 2 plus 2 times xy plus y squared. Now, if we take the 2xy on the right hand side and then take it to the left hand side, it now becomes minus 2xy. And that's why the overall term, if you look at it below, it is now x plus y all squared minus 2xy. And we are left with the x squared plus y squared on the right hand side. And this gives us equation 1. Now, let's go ahead and see another form of mathematical expression, which is x minus y all squared, and that gives us x squared minus 2xy plus y squared. Remember, this is x minus y. This time around, you will have the minus 2xy as against the plus 2xy, but all other parameters remain the same, as you can see above, where your x plus y all squared gave us x squared plus 2xy plus y squared. This time around, because of the negative sign, x minus y all squared will give us, on the right hand side, as can be clearly seen, x squared minus 2xy plus y squared. Now, if we take the 2xy, which as it is represented now here on the right hand side, is minus 2xy. If we decide to take it to the left hand side, so that we can have x squared plus y squared alone on the right hand side, this now gives us the expression. So you have your x minus 2, you have your x minus y all squared. Now you have your minus 2xy, which was on the right hand side, crossing over to the left hand side, now becoming plus 2xy, and is equals to what you have left on the right hand side, which is x squared plus y squared. This is equation 2. Now, before we move to the next slide, look at equation 1 and compare it with what you have on top, the x plus y. Do you have an x plus y in equation 1? Yes, you do. Do you have an xy in equation 1? Yes, you do. Therefore, you can use equation 1 to solve the problem by simple substitution. Now in equation 2, do you have an x minus y in the question? The answer is no. Do you have an xy in the question? The answer is yes. So because you don't have all that you need to substitute, therefore equation 2 will not be applicable. So what we have again is x plus y is equals to 9 and our xy is 20, and we are looking to solve for x squared plus y squared. Now we will be generating another mathematical equation to see whether it will also be applicable to use to solve the question. Now, if you look at the right hand side, you see your x squared minus y squared. This is what they call the difference of squares. And that gives your x plus y into your bracket x minus y. So whenever you have a difference of squares, assuming you have, if you have something like a squared minus b squared, what you have is a plus b into the bracket a minus b. So this is the same as what we have above here. The only thing is that while a squared minus b squared is on the left hand side, your x squared minus y squared is on the right hand side. So your difference of squares, in this case in equation 3, x squared minus y squared, is simply your x plus y into the bracket of x minus y. But the question you ask is, does this equation, will it be able to solve our equation x plus y is equals to 9, and then xy is equals to 20? Is it going to be applicable? Let's check it now. So in this equation here, you have x plus y, and in the question you have x plus y, which is 9. You have x minus y. Do we have it here? We don't have anything. So we only have xy is equals to 20. Therefore, we cannot use this equation. So equation 3 will not be applicable for us to use. Therefore, we will be using equation 1. Equation 1 being x plus y all squared minus 2xy is equals to s squared plus y squared. All we need to do now is to substitute. We have x plus y and is equals to 9. Therefore, x plus y here, we will substitute and put 9. Here we have xy and is equals to 20. Therefore, our xy here, we will substitute it as 20. So we have 9 squared minus 2 into the bracket of 20 is equals to s squared plus y squared. Remember, all we are doing is to substitute. And once we substitute into equation 1, we are able to solve for x squared plus y squared. So here, our x plus y is 9, and therefore 9 squared minus 2 into the bracket xy. Our xy is 20, therefore minus 2 into the bracket of 20 is equals to x squared plus y squared. So what we'll be doing now is to simply simplify. Our 9 squared will be 81, and then our minus 2 times 20, if we're opening the bracket, will be 40. Therefore, 81 on the left-hand side minus 40, which is 41, is equals to s squared plus y squared. Therefore, our answer, s squared plus y squared, is equals to 41. I'd just like to do a quick further explanation on equation 1, how equation 1 was obtained. Remember that x plus y all squared is the same as what? X plus y into the bracket x plus y, because you're multiplying it twice. And that's why on the left-hand side, you are saying x plus y squared. Now, if we expand this, all we need to do is to bring out the value of x here and multiply it by x plus y. And that's what gave us this. The value of x, we're multiplying it plus x plus y. I want to believe that is clear. So what we will now do is we will now take the value of y and multiply it by x plus y. And that is what we have here, the value of y, and then we multiply it by x plus y. So when we expand this, x times x, we have x squared. X times xy, we have xy, and then y times x is yx, which is also the same as xy, and then we have y times y is y squared. So that's what we have when we try to expand this equation. All I'm doing is trying to explain how that equation 1 was obtained. Remember here we have s squared, then we have xy plus xy. They look alike, right? An apple plus an apple will give you 2 apples. So xy plus xy, when we simplify it, it will give us 2xy. Then we have this here. And that's why when you add your xy plus xy, it gives us what we have at the bottom here as 2xy. So if we simplify everything out, we have x plus y all squared is equals to s squared plus 2xy plus y squared. And then what we just simply did was to take the 2xy on the right hand side to the left hand side, and then now becomes negative 2xy. That is x plus y all squared minus. This now becomes minus because it's crossing the equality sign. So that was just the reason why I just decided to take time to explain how we got equation 1. But generally in simple terms, your x plus y all squared gives you x squared plus 2xy plus y squared. Remember I said if it is a plus b all squared, it will be a squared plus 2ab plus b squared. So this time around, we'll be looking at the second equation and trying to explain it much more clearly. And what we have for this second expression is x minus y all squared. And that tells me on the right hand side, we'll be multiplying x minus y and multiplying it by another x minus y. So there are two x minus y multiplying themselves. X minus y multiplied by another x minus y. So what we'll simply do is we will keep x minus y constant and then multiply it by the first x. Then what we'll do next is to keep x minus y constant and then multiply it by minus y. Let's see how this plays out. So just as we had mentioned earlier, what we'll do is to multiply x, which is this x, with x minus y, and which is this x minus y. So that gives us the first expression. The next thing we will do is to multiply this minus y, which is what we have here, with x minus y, and that's what we have here. So that's how we got this expression in this line. So the next thing we will do is to expand this expression. And in expanding this expression, we'll take this x and multiply this x. And then similarly, we'll take the same x and multiply minus y. And then we will take this minus y to multiply x, and then take the same minus y to multiply minus y. Let's see what we get in this expression. So what we have here basically is, like I said, x into the x in the bracket, we have x squared, x into the minus y, we have minus xy, and then when we move to the other side, we have minus y times x, which is minus xy, and then minus y times minus y, we have a plus y squared. Now what we can do to finish up is to simplify. You have a minus xy here and a minus xy. You have a minus apple and a minus apple. You are owing an apple and you owe another apple. It means you are going to owe two apples. So in simplifying, we have our s squared minus 2xy plus y squared. And that's what gives us on the left hand side x minus y all squared. So if we take the minus 2xy and then we take it to the left hand side, it now becomes x minus y all squared plus 2xy, and that gives us s squared plus y squared. And that's how we got equation 2. But if you look at this at the top, the question is, do we have x minus y in the above question? The answer is no. Do we have xy in the above question? The answer is yes. But since there's one unknown and then the other one is known, we cannot fully solve this equation using this expression. But the reason why we are running through this is because some other question may require that our x minus y may be 9 or may be another term, and that will make this equation 2 applicable. So same thing with the third equation. The third equation is not applicable because it doesn't have, it has an x plus y here, and that x plus y is equals to 9, but it does not have an x minus y in this equation. Therefore, this equation 3 is not applicable. It's not applicable. So that was the reason why equation 1 was used and substituted in order for us to have our s squared plus y squared as 41.